So today we're going to talk about solving absolute value equations. So if you remember from pre-algebra, absolute value is the distance a number is from zero. So for example, for absolute value, you'll see these straight bars next to the number, and the number would be in between. So if I ask you what is the absolute value of 3, the answer is 3. It's 3 units away from 0. But if I ask you what's the absolute value of -3, it is still 3, because -3 is still 3 units away from 0. So when we evaluate absolute value, do everything inside the absolute value first. So here, the absolute value of -8 is 8, but then there's a negative sign here, so this is still -8. Absolute value of 8 is 8, but the negative sign's on the outside, so this would be -8. I'm going to do everything inside the absolute value first. 2 minus 4 is -2. Absolute value of -2 is 2. Absolute value of 5 is 5 minus 5 minus 8 is -3, but the absolute value of -3 is 3, so 5 minus 3 is 2. Okay, now let's go through and solve some absolute value equations. So if I just ask you, there's a number whose absolute value is equal to 5, and you're asked to find that number, the two solutions would be x equals 5, because the absolute value of 5 is 5, and you could also have -5. So notice that absolute value equations, there are always two solutions, and that will always be the case. Except, look at number 8. The absolute value of some number is equal to -3. Well, the absolute value of any number always has to be positive. So this can never happen, so this is a no solution. So anytime you have the absolute value by itself and this number on the right is a negative number, it will always be a no solution. So what do we do in cases when you can't tell easily what the solution are? What we're going to do is we're going to set up two cases because there are two answers that make this a true statement. Basically, one scenario is, what if the number inside the absolute value is positive? So x minus 5 is equal to 2. So if I solve this, plus 5, x equals 7. And if you plug it back in, it should make sense. 7 minus 5 is 2. Absolute value of 2 is 2. The other scenario is what's inside the absolute value can be the opposite. So if you look back here, if we put in a -5 or the opposite of what's out here, you will get the same answer. So one way to set this up is say, okay, you can take the opposite of everything inside the absolute value, and that can also be equal to 2. Now, instead of distributing right away, you can divide by -1, and you can get to here right away. So what I typically recommend people to do is when you set up your two cases, just rewrite the original problem exactly as is. Your second case will be the original problem, but then this number, just make it opposite. So if I add 5, x equals 3 is my other solution, and if you check it, it should work. 3 minus 5 is -2, but the absolute value of -2 is 2. Okay, let's try the next example. So I have the absolute value by itself. So my first scenario is this. 3x minus 2 equals 10. I'm going to add 2. 3x equals 12. Divide by 3. X equals 4 is one answer. The other one, 3x minus 2 can also be equal to -10. So solve it. 3x equals -8, divide by 3. So x equals -1/3 is the other solution. Okay, now in some cases, before you set up the two cases, you will have to do something else first. You must isolate the absolute value. That means if you have anything outside the absolute value, you have to get it by itself first. So notice this 5 is outside the absolute value. In order to get rid of that 5, the 5 is being multiplied with everything inside the absolute value, so the inverse operation is to divide. So I'm going to divide both sides by 5. The absolute value is still there, but now I end up with this. So your two cases are 2x minus 1 equals 1, 2x minus 1 equals -1. Okay, solve, plus 1, x equals 1, plus 1, 2x equals 0, divide by 2, x equals 0 is your other solution. I would pause the video at this point and you try the next two examples on your own and then come back and check it. Okay, so number 12, I see lots of stuff outside the absolute value, so you want to get rid of it first. So I see this minus 2. So I'm going to plus 2 first. I have 3 minus absolute value of negative 2x minus 2 equals 12. This 3, it's a positive 3, so I'm going to minus 3. Keep that negative sign outside. This is 9. This negative is the same as really a negative 1 here. So in order to get rid of that, you're going to divide by negative 1. So I get 2x minus 2 equals negative 9. Notice all this work just to get the absolute value by itself, but notice you have the absolute value by itself and it's equal to a negative number. The absolute value of a number always has to be positive, so as soon as you do see this, you don't have to do anything else. You know this is a no solution. There are no numbers I can plug in for x to make the absolute value of that be negative 9. The last one, okay, I see other stuff outside the absolute value, so let's get the absolute value by itself. So we always add and subtract stuff over first. So I'm going to subtract the 5. So I have 2 absolute value of x plus 7 equals negative 2. I'm going to divide by 2 because there's no operation, so that means that it's being multiplied. Again, same thing happens. I have the absolute value by itself. It's equal to a negative number, so this is also a no solution. Okay, so when you see an absolute value equation, these are the steps you have to get to. You must get the absolute value by itself first. So you want to get it something in this form. Now, here's a special scenario. If this number c is negative, this is a no solution. You're done. Okay, if that c is not negative, then you must set up your two cases, which are x minus a equals c, x minus a equals negative c, and then you're going to go ahead and solve for x to get your two answers.